Trini, how are you? How was your morning?
Okay, teacher.
Anything you want to ask?
No.
What do you plan to do after your exam?
I don't know, teacher.
Go and do some part-time work, lor, just to keep yourself busy, give you a idea of what working life is. And then you may have to consider seriously what you want to do after that. Whether you want to go to university or whether you want, if your result is poor, what you want to do. If your result is good, which university you're planning to go. These are things you have to start planning, no? Maybe STPM is not suitable for you lah, because it's too mathematical. You want to consider doing an Australian program, no? Either Murphy or OSMAC. Anyway, that's for you to think about. You can talk to me later on if you want to discuss further.
I just want to pass this paper and move on, lah, teacher.
Okay, put in your effort, lor.
Enough to go into university so that I don't retake the, I don't do the other foundation program, straight can go degree.
Okay, let's go to focus then. Good that you are ambitious. Right? For nucleus, you need to know all this. And then for radioactivity, prepare your own in a short page there, all the things that you need to remember. And then nuclear reaction, all the things that you need to remember. Okay, let's try some question. Okay, what's the answer for this one? If the masses of proton and neutron, electron, and carbon-12 atom are MP, Mn, Me, and Mc respectively, the mass defect delta M of the nucleus carbon-12 is given by, what is the answer?
C.
Okay. Yeah, working is a bit poor lah, right? Working in the book there is a bit poor. They give working more like D. Okay, good. How about this one? Number 2, the nucleus of iron is more stable than the nucleus of bismuth. Which of the following is true of the stable nucleus?
Donkey.
Donkey, higher binding energy per nucleon. Okay, good. How about number 3? Function of control rod in a nuclear reactor is to
C.
okay, control the rate of reaction by absorbing neutrons from chain reaction. Okay, number 4, calculate the energy release in the reaction helium to form beryllium and gamma ray.
Mass defect, calculate lah. You plus the 32He and 42He plus, and then minus the thing.
I know,
minus the right side one.
You should have calculated out.
Boy.
Right? Find the mass defect. And then times 934. I've given you 934 to convert to energy. Okay, good. How about this one, number 5? The isotopes carbon-14 decays into nitrogen-14 by emitting a beta particle. Which of the following statement is true?
Donkey.
Beta minus decay, a neutron converts to a proton with emission of electron. Donkey, okay. Number 6.
Boy.
A radioactive element X decay to a radioactive element Y and then decay to an element Z. If initially there are only X, which of the following influence the ratio of the number of nuclei of Y, to that of X? Okay, boy, half-life determines the rate of decay. So if Y decays faster, the ratio will be smaller. Number 7, a nuclear reaction in which involves...
Yeah, go back, Jeff. Teacher,
Yeah,
do you think I can still do it, Teacher?
it's really up to you. As I say, it's hit or miss. If it comes out what you study, because you have not been putting in the effort. I've always told you, I've been scolding you, to tell your parents, but you are not doing anything. So it's a hit or miss. If you believe that you are, it depends on how you know your physics. If your physics is not very well, then you are confident to do the question, then you are okay, you should be able to do well. But if you are still struggling to do the past paper, then you will struggle in the exam.
Okay.
Anything else you want to
No,
ask?
Jeff.
Okay, number 6, okay or not? Need me to explain further?
No.
Just go off for a little while. Nothing happened. That's why I told you the STPM is not suitable for you. Maybe you are struggling. You don't like the course at all. It's too demanding on you. Right? That's why I always suggest you have to think seriously. If you can go to university, good. If you cannot, then you have to evaluate yourself honestly. Have you put enough effort? Or maybe STPM is not suitable for you. You are struggling through all the subject. You have to ask yourself honestly, and then talk to your parent, discuss with them what you're going to do next. Okay?
So let me keep moving on, lah. Don't think about past.
If you can go to university, of course, go ahead. No need to repeat. But if you cannot make it, then you have to think honestly. Is STPM suitable for you? Are you finding it too challenging? Then if it's too challenging, you have to consider doing some other program. Or if you feel that you want to, if you are a hands-on person, then go to work. No?
Oh, no. My dad wants me to study, lah.
If you want to study, then you have to think of alternative. No? If you fail, what you want to do alternative. If you pass, which university you want to go to, that's the thing they have to think through. No? Okay.
Okay.
A nuclear reaction which involves carbon-13 and hydrogen is suggested as follows. Which of the following is true of the nuclear reaction? You have to do calculation, no choice for this one. Whether it release energy or... Say again.
A.
Calculate the mass defect. No need to calculate everything. As long as the mass defect is positive, then energy is released. A, okay. Okay, number 8. A radioactive nuclide of mass number M1 decays by emitting beta particle and gamma rays to produce nuclide of mass number M2. Which of the following is true of the relationship between M1 and M2? Yep. What's the answer?
C.
Okay. The mass of beta is very small. Slight changes only from a proton to a neutron or neutron to a proton, depend on the whether it's minus, beta minus or beta plus decay. So the difference in mass of electron is very little. So M1 equals to M2. Okay, good. Tomorrow we do partial paper. Nuclide decays by, we only got 3 lessons. Saturday, unless you want to have further more lessons, I don't know. You only have Saturday, then next Friday, next Saturday. After that, maybe you want to spend more time preparing for your exam. A nuclide decays by emitting alpha particle and Y beta particle to form an isotope of original nuclide. What are the values of X and Y? Yep.
A.
In alpha decay, A decreases by 4 and Z decreases by 2. Okay, so in a beta decay, beta minus decay, sorry. Beta minus decay, A is constant, A doesn't change. Z increases by 1. So there is a decrease in 2 here. So increase to Z, to beta. So you're right. You want the beta to be, you want the Z to be the same, right, as the original Z after the alpha decay. So answer is A, good. Okay, we're not going to do all, don't have the time to do all. When a slow neutron is captured by stationary cadmium nucleus, a cadmium-40I nucleus is formed and a gamma photon is emitted. What is the wavelength of the gamma ray? Okay.
C.
Say again.
C.
How do you calculate?
How do I calculate?
Ah.
Okay. the mass for 113 CD and 1141 you plus together, then you minus with the
Say again. Mass of what?
the 11348 CD plus with the mass of 10 neutron, and then minus with the 11448 CD equals to Hc lambda.
Okay, so basically you take your 113 plus the mass of neutron minus the mass of 114, then you get your atomic mass unit. Then after that, that mass convert to energy. Right? That's that. If you can use 931, if you want, you can use that straight away to mega electron volt. But here, I think they want it in wavelength. So the mass, you have to convert it first, right, to kilogram. So you have to use your value of constant. One atomic mass unit equals that. Then times the speed of light. Calculate that in joule. And after that, use your that equation, right? Lambda cross multiply. Hc, that's your energy. E, put it inside here. And you get your answer C. Okay, good. The high energy particle which is emitted when a beryllium foil is bombarded by alpha particle is this one is memory work only.
Boy.
Okay, good. Neutron. How about this one? Geiger-Mahler tube is placed at a certain distance from the source of radioactive. The count rate R is recorded for a long period of time until the count rate from the source is extremely low as compared to the count rate of background. Which graph shows the variation of count rate with time? Yep, what's your answer? Yep. Why so long? Yeah. Actually, don't cheat. Don't look at the answer. Do your honestly. If you can do, means you are doing very well. You cheat yourself only. Right? Should decay. And then after that, should more or less constant. Because the background is more or less constant. So A. A nuclide P decays into Q by emitting 2 alpha and 1 positron. What are the values of A and Z? Yep, what's the answer?
Boy.
2 alpha, A will decrease by 4 times 2 is 8. Z will decrease by 2 times 2. So it's 4. Then for your beta decay, beta plus positron decay, A is constant. Z decreases by 1. So A will change by, right, it starts with 210 minus 8 is 202. Z, right, it starts with 81. So 81 minus your 4. And now decrease minus 1, 76. So B, okay. How about number 16? I'm not preparing any quiz already because we are running out of time. So I just review with you what are the things you need to remember for tomorrow, and then I will answer your question.
A.
What is the decay constant of a radioactive element? The probability of a nucleus decaying in 1 second. Okay, A, good. The half-life of polonium is 138 days. If the mass of a sample of polonium is 1 gram, what is the number of nuclei that decay in 1 second? Yep, you want to find activity, you should be able to interpret the answer. Activity. So activity is just n times your lambda. Calculate your lambda. Calculate your n. Can? Right? Calculate your lambda. These are given there. Put inside there. Right? Convert your day to hours times 24 to second times 3,600. Okay, so it's per second. Then your activity, your n, right, number of mole is n number of atom over Avogadro's number, or mass divided by relative mass. So you want to find n, right? Take your Na across. Okay, mass is 1 gram divided by 200, right? 210 gram. And your Na, get it from the data sheet. Then the activity is n times lambda. That's your n, that's your lambda. Multiply out, answer is B. Okay or not?
Okay.
Okay, let's see which question I want to ask after that. 18 and 20. Okay, what is the binding energy per nucleon of copper? Yep. Calculate your total mass of nitrogen. Right, you got 29 hydrogen. This one, 29 times hydrogen. And then 63 minus 29 is 34. 34 neutron, mass of neutron. And minus the mass of nucleus. Get atomic mass unit. That's a conversion from mass to energy. Right, no need to use delta mc square already. Just that one there, mass, that's 934. Then divide by your 63. Right? Total number of nucleon is 63 there. So get the answer C. Okay, anything not clear?
Clear, sure.
Okay, let's do structure after this last one. Radioactive sample contains 3.2 times 10 to the power 18 atoms of particular nuclide and emits 3600 alpha particles per second. Calculate the decay constant of the radioactive nuclide. Yep. This is your N. This is your activity. Okay. Basically, we are using this formula. Lambda is take the N down. Okay, that's activity. Activity. That's all. Straightforward. B. Anything? Anything not clear? Must know how to use all this formula. Okay, if no question, let's go to structure question. A radioactive sample contains 15 grams of radon 222. It's estimated that the source emits 2.061 times 10 to the power 18 alpha particle per second. Calculate the half-life. Same as what we just did. Have a go and tell me the answer. Yep, what's the answer? As always, go to this formula. Number of mole, number of atom divided by Avogadro's number, or mass of the substance divided by molecular mass of the substance. Right? Then to calculate your N, you take your Na across there, put in your value in 15 grams, and this is 222. Okay? And Avogadro's number, count your N. Okay? Just using this formula, calculate your decay constant first, A over N. Okay? That's your N. That's your A. Then after that, use your half-life formula, ln 2 over lambda. Okay. Anything that's not clear? Yeah. Anything not clear?
Clear, sir.
Describe thermonuclear fusion in the sun. Yep. Can describe for me? Can or not? Right? At very high temperature in the sun of about 10 to the power 10 Kelvin, hydrogen atom exists as ion, or we call it plasma. The high kinetic energy of the ions allow the hydrogen ions to overcome electrostatic repulsion to form helium. The hydrogen and hydrogen ion collide to form helium. The energy is radiated is equal to the mass defect, or the mass defect converted to energy that is given out. The intensity of radiation of the sun on the earth is 1340 watt per meter minus 2. The mean distance of the earth from the sun is 1.5 times 10 to the power 11 meter. Calculate the radiant energy of the sun in a year. Okay, what should I do? Yeah, what should I do? What formula to use? Any idea?
Intensity formula.
What intensity formula?
I equals to P over 4 pi r square.
Okay, let P be the power and R the distance from the center of the sun to center of the earth. Okay, so power divided by 4 pi r square. Okay, that's the definition. The power divided by area. What we are doing here. Then we're going to find power, cross multiply, and put in your value. Right? That's the intensity. I, R, that's the distance. Square that. Calculate out. Right? Power is E over T. Right? E is PT. That's your power. That's your time. Right? 1 year. Okay. Anything that is not clear? Okay, if no question, let's go to number 3. In a nuclear reactor, a very slow moving neutron is absorbed by a stationary boron atom. The equation for the nuclear reaction is given. After the reaction, the speed of the helium is given, and the kinetic energy of the neutron is approximately 0. Calculate the kinetic energy of the lithium atom after the reaction. What should I do? Yep. What should I do? What should I do? No idea. Applying the principle of conservation of momentum. Right? That's your first semester, first term work. Mass of lithium and velocity of lithium, mass of helium and velocity of helium. Right? You are told that this is 0. So we assume this is 0 also. Right? Initially is 0. These two initially is 0. Then velocity of lithium is what we want, right? Divided by ml. Take across, of course, you got a negative sign now, but don't bother about negative sign now. Right? Take the negative, just sign, show the direction only. Right? Put in your value, helium, as a helium. Right? No need to convert it, you can just use that. Velocity of helium is given. The one there. Mass of lithium is given. Okay. Reaction energy, then you have to subtract. So you have to calculate kinetic energy. I haven't complete yet. Calculate the speed, the velocity only. Put your mass of lithium. Right? This atomic mass unit, convert it to kilogram, times 1.6 and 10 to the power 27. And then times your V square. That's your V square. That's your V. Right? Square that. 1.71 times 10 to the power minus 13 joule. Okay or not? Anything that's not clear? If okay, let's go to part B. Yep. Talk to me. Are you okay? Any comment or anything to ask? Any step not clear? I didn't put a negative sign there because it just show the direction only. Okay, now Srini, anything not clear? Come on, talk to me. Anything that's not clear before we go to the next part? Turn the video on. I want to see what you are doing. How come you are so quiet today? What is happening? Are you all right, Srini? Or you got cut off again? Yep. Srini, talk to me. What is happening? Anything that is not clear, I explain to you again. Put your video on. I want to see what is happening. Why are you so quiet today? Srini, what's happening? You got disconnected or what?
Hello?
Yeah, what is happening?
I got disconnected, teacher.
That's what I suspect. Okay, which part you not clear? Very
Clear,
unstable.
sir.
Can calculate?
Can.
Can. Let's go to part B. What should I do, part B? What should I do? Yep. Tell me the step. What should I do? Just calculate the mass defect. Oh. Right? Mass of neutron, mass of boron. Right? Mass of neutron is there. Mass of boron. And subtract mass of lithium. Mass of lithium. Subtract mass of helium. That's your mass defect. Then you need to convert the energy. Right? Most likely they want it in joule. Delta M and C square. Right? That's atomic mass unit. Convert it to kilogram times your velocity or speed of light. Okay. Yep. Talk to me. Anything that's not clear, or you cut out again?
Clear, sir.
Okay, let's try one last
Oh,
one, number 4. Say again.
Sir, by the way, right, teacher,
Yep.
I watched until the chapter 4, the video, very good, teacher. Now I understand it better.
You mean this semester one?
Yeah.
Good to hear that you are revising. Good to hear that. Continue
I mean, got
to
another 3 more chapter, but I should be finished by this week, lah, teacher.
continue to improve. You should be starting your partial paper already.
Yeah, I will start soon as I finish the video, sir. Then I should be prepared, lah.
Okay, good. Good to hear that you are using the video to your benefit. The
Yeah,
initial,
but then sometime I always hear the video, you always scold, so I feel guilty a bit.
no choice. You don't want to put in effort to study what to do. So I have to scold you lah. Hopefully you will motivate you to study.
Yeah, I just want to pass this, lah. I want to go college only. So,
Okay, initial number of atoms in a 2-gram radioactive element is 6 times 10 to the power 21. The half-life of element is 10 hours. Calculate the number of atoms that decay in 24 hours. Okay, what should I do? Yep, what should I do? What formula should I use?
what formula? N equals to bracket 1 over 2 power x and naught.
Right. First thing you have to calculate is your lambda t. Right. Ln n t half. T half is 10 hours. So I'll calculate the lambda in terms of hour per hour. Then 24 hours. Then I can use this formula or the other formula, either one. Okay, your N naught, that's your N naught. Lambda T, that's your lambda T. Calculate out. Number of atoms decay in 24 hours. Okay, you have, that's the original amount. Number decay. number of atoms. Calculate the number of atoms decay. So number of atoms decay is just the original number and the number that is decay. So that's what you get. Okay now. Anything that is not clear? Right? We have calculated the number remaining. This is the number remaining after 24 hours. Right? Determine the mass of radioactive element left. How to do that? How to do that? The told initially is 2 grams. What should I do? Yep. What should I do? Same, using the same formula that I've given you. Your mass is proportional to the number of atoms. Right? And there's a constant. And use that. M, right? That's after 24 hours. This is the initial amount. M naught initial mass for a number of atoms initially. So take the N across there. Right? M naught is 2 grams here. N naught is the initial number given. That's the initial number. N is the number left after 24 hours. That's all. Can? Anything you don't understand? How's your second term work?
I haven't revised yet, teacher. I was revising the SEM 3 one only.
Okay, anything that's not clear that you want to ask?
Clear, teacher.
Okay, let's go to essay question. Why does fusion reaction take place at high temperature? Yep. You need to review after I teach you. If not, you are going to waste of time only. I have to give you all the
Yeah,
answer.
the what's that? The school teacher gave me compilation of past year. I need to start doing that. So but then after I'll be okay already.
You must review. If not, it's a waste. You come to tuition, it's a waste of money. I give you all the answer only. I'm the one working. You're not working at all. Right? This one is wrong. It should be carbon rather than copper. Right? At high temperature, kinetic energy of the reactant is sufficiently high to overcome the electrostatic repulsive force between the positive nuclei for fusion to occur. Right? Remember the 2 hydrogen atoms. Right? If you are going to push the nucleus to fuse, they are both positive charge, so they will repel each other. So in order to overcome that, you have to increase the temperature or accelerate it to high kinetic energy. Right? So one way is to increase to high temperature, then the kinetic energy is high enough for them so that when they collide, they will fuse together. Calculate the energy released in the following fusion reaction. Okay, how do I do that? Yep, what should I do? Right? Calculate the mass defect, no? Right? Mass of carbon, right? Which is this one, plus hydrogen, which is given here, minus that one, nitrogen. So your unit is atomic mass unit, and they are given you conversion to energy and times 931. Then you get your 7.55 times 10 to the power 7.55 mega electron volt. Explain briefly the control fission reaction in nuclear reactor. Yep. Can see that I have to scold you because you didn't study. So I have to give you all the answer. That's why I say it defeats the purpose of coming for tuition. Supposed to be only answering your problem rather than giving all the answer. Water is used as a moderator to slow down the neutron. Right? Fast neutron cannot cause a reaction, only slow neutron. Control rod made of cadmium are used to absorb 2 out of 3 secondary neutron. Right? You don't want the chain reaction to occur too fast, right? Unless too much heat is produced. So that's the reason why you have the control rod to absorb some of neutron so that the fission reaction occur at a constant rate. You want to control the rate of reaction so that enough energy, we can take the energy out. The heat energy that's produced, we can remove them. Okay? Any comment?
No, sir.
Okay. Which one should we do now? Let's try number 2. Define half-life and decay constant of radioactive element substance. Okay, define for me. See whether you can remember. Can?
Can.
Yeah. Define half-life. What's half-life? Yep. What's half-life? It is the time taken for the number of radioactive nuclide to decrease to half its original number. Then decay constant. Okay? Decay constant equals to rate of decay of radioactive atom divided by number of radioactive atoms. Number of radioactive atoms in the sample. Carelessness. Cannot write formula. Okay, you have to explain the formula that you write. What does the symbol stand for? Right? Even though we are doing that. Right? Okay, constant for that. So rate of radioactive atom, that's the rate. And number atoms in the sample. Okay. Or you can define it as probability of decay per unit time, no? Okay, see whether you can write for me part B. B part 1, naturally occurring radium-226 with atomic number 88 produce radioactive gas radon by alpha decay. Write down the equation for me.
22688 radian and convert to 22286 Rn plus 4/2 He.
That's all. 22688 to Rn and alpha. Okay, try to calculate for me, since I've been doing for you so many times. Calculate the total kinetic energy of the decay product in mega electron volt. How should I do? Yep. What should I do? What should I do? Can or not? You can see you have not reviewed what I teach you. That's why you are struggling. I've done so many times for you. Right? Calculate the mass defect, original, that mass there, radium, minus the mass of these two, mass of radon, mass of helium. Right? This is the atomic mass unit. And they want it in energy. They give you the conversion. Multiply by that. That's a conversion. So how do I calculate the total kinetic energy in mega electron volt? Yeah. Any comment? Calculate the energy right release. So how do you calculate the total kinetic energy of the decay product? That's the decay product. Radon and helium. Or radon and alpha particle. This is energy. This is the kinetic energy. Right? Just write another step. This is the total kinetic energy of the decay product. Okay, anything that is not clear? Okay, now Srini. Okay, let's go to part C then. Give 3 reasons why radioactive isotopes are useful for medical diagnosis. What are the 3 reasons? Right? High penetration of gamma ray. If you use gamma ray, emission from radioactive isotope in the body can be detected by detector that is outside the body. Produce ionization used in radiotherapy to destroy cell. Radioactive isotope retain its activity, whatever compound the atom is attached to, used as radioactive tracer. Right? That's the advantage. The usefulness, it doesn't matter whether the radioactive isotope that are introduced in, it can combine with other atoms to form compound. So it doesn't affect it, it's still radioactive. And can use that as tracer where the particular isotope has moved from where you have put it into the body. A doctor used 1.49 microgram of iodine to treat thyroid disorder. Iodine 131 has a half-life of 8 days. Calculate the number of nuclei initially present. Yeah, what should I do? You have been calculating this. That's why I say you are not. That's why I have to scold you because you are wasting your parents' money for tuition. Because you don't bother to put an effort to do your homework. So you end up, I have to do all your homework for you. Any idea?
I know, teacher.
Same. You want to calculate number? Use that one. Number of mole equals number of atoms divided by Avogadro's number, or mass of the substance divided by molecular mass of the substance. Okay, that's your Avogadro's number. Take it across there. Right? That's the not present initially. And then this one, right? The molecular mass. Okay, that's how you calculate. Initial activity, what should I do? How do I calculate the initial activity? You can see I've been teaching you all the while and I'm calculating the same thing, you still cannot. That's why I have to scold you. Right? You didn't put effort. Activity is n and lambda. We calculate the n. Next thing is calculate your lambda. That's your n. Lambda is ln 2 over half-life. Half-life given 8 days and 24 hours to change to hour and 3,600 change it to second. Okay, I think I won't go any further unless you got question to ask. If not, I will stop here. Anything that is not clear?
Stop here, teacher.
Stop here.
Stop here, teacher.
Okay, I think we will stop here. So remember, tomorrow, past year paper, you are supposed to do your part and ask question. Since you say you have reviewed 4 topics, you should be able to do the past year paper. We were expected to do at least about two topics tomorrow. Okay, if there's no question, we'll end today.
Yeah.
Continue to work on your, as I say, it depends on you very much. If you find you can answer the past year question, then you are ready for exam. So since you have reviewed 4 topics, you should be able to do the past year paper now. So have a go at it tonight. Okay?
Okay, teacher, sure.
I'll stop it now.
Teacher, but I don't know why, teacher.
Mm.
Like for the each topic, right? Topic 1, 5 hours, topic 2.